about some of these different postulates and theorems and properties to help you to remember which ones are which. So for example, in number 1, this to me looks like a reflection. When A is equal to A, I'm going to say that number 1 goes with the reflexive property, or I. In number 2, if A is equal to B and B is equal to C, then A is equal to C. This reminds me of a train. If the first car is connected to the second car, and the second car is connected to the third car, then the first car is connected to the third car. So since that reminds me of a train, that reminds me of the transitive property. In number 3, if to this equation I add C on this side, and I add C on the other side, then I've added something equally to both sides. So when I add equally, we call that the addition property of equality. In number 5, when I see the word substituted, then I know right away that that's the substitution property. If I begin with the equation A equals B, and I subtract C from the left side, and I subtract C from the right side, and I do that equally, then that's the subtraction property of equality. So that leads us to number 10, where once again, in this original equation, I've subtracted RS from the left side, I've subtracted RS from the right side, so we call this the subtraction property of equality. It's our abbreviation for property of equality. In number 12, if this original equation, I'm adding the measure of angle QRS to the left side, and I'm adding the measure of angle QRS equally to the right side. We say this is an example of the addition property of equality. When I have something that's equal to 3 inches and something else that's also equal to 3 inches, then I can substitute in this situation to say that these two somethings are equal to each other. We call that the substitution property. All right, here's a problem where we're asking to write a 2-column proof. So in a 2-column proof, one of the most important things is the diagram. We're going to take a look at this diagram to help us with the proof. To begin the proof, we're going to set up 2 columns. In column number 1, we're going to write all of our statements. And in the second column, we're going to write a reason for every statement. Let me give you an idea of where we get our reasons from. Sometimes a reason can be a definition. Sometimes a reason can be a postulate or a theorem. important to know my definitions, theorems, postulates, and properties so that I can use them as reasons in my proof. In a proof, we begin with the given. We always number each statement along with each reason. So statement number 1 is that segment KM is congruent to segment LN. Now, because I'm going to be writing some statements of equality, I'm going to change from using a congruent sign to an equal sign. So in my very first step, what I notice is that KM, segment KM, is made up of 2 parts. KM is made up of KL plus LM. When we take the 2 parts of a segment and break them down, we call that the segment addition postulate. So there we've used a postulate. Now, by the same reasoning, I can also break down segment LN into its 2 parts. So in the same step, I'm going to say that the measure of segment LN is made up of the measure of LM plus MN. And because I use the segment addition postulate for that statement, I'm going to keep number 2 the same reason. Because KM is congruent to LN, I can now say that KM, which is made up of KL plus LM, is equal to LN, which is made up of LM plus MN. So I took equal parts and replaced them or substituted for the substitution property. So now I've used the property. Because LM is a segment on both sides of my equation, I can subtract LM from both sides, leaving me with segment KL is equal to segment MN. Since I subtracted equally from both sides, the subtraction property of equality. So I now used another property. Now, my proof is asking me to prove that segment KL is congruent to segment MN. So I'm going to add my last step here. Segment KL is congruent to segment MN. So we're just going to say by definition of congruency. So I've also used a definition. So here's an example of a proof that used 3 out of the 4 different types of reasons in writing a proof. For question number 18, I'm going to give you an example of a paragraph proof that they wrote to prove that angle BZX, that's this angle right here, is congruent to angle WZY. WZY is this angle right here. So let me show that, uncover that for you, and you can read that on your own. 20. The relationship between these two angles is that they are vertical angles. And vertical angles are congruent to each other and are equal in measure. Therefore, I'm going to say that 47 degrees is equal to 3x plus 2. In number 22, the distance from A to C is 37. The distance from B to C is 5x plus 8. Distance from A to B is 8x plus 3. In order to find BC, I first have to solve for x. So I'm going to write an equation that will help me to solve for x. That equation would be 8x plus 3 together with 5x plus 8 has to equal a total of 37. So now that I know what my value of x is, and I want to find the distance from B to C, I'm going to take out x and replace it with the number 2. So 5 times 2 is 10 plus 8 is equal to 18. So BC is equal to 18.